Hello everyone. Today I will be talking about water desalination using silver dewetted on CNT materials and microfluidic channels. Drinking water crisis is one of the biggest challenges the world is facing right now. The global demand of drinking water has been increasing rapidly for the past years despite the evolution of water treatment technologies. The United Nations estimates that by 2025, half of the population will be living in a water-stressed area. The global water crisis is due to water pollution, climate change, population growth, wetter regions becoming wetter, and drier regions becoming drier. The vast majority of the growth in demand for water occurs in countries with developing economies like sub-Saharan countries in Africa and South Asian countries as shown on the map. As of today, there are three main water desalination techniques. The first one is water distillation, which uses heat to separate water from the salts. The second one is separation of ions with electrical currents. And the third is filtration. In recent years, filtration has been the most used method. Filtration can be done by reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. All these desalination methods work, but they often require a lot of energy and they have a big carbon footprint. In recent years, scientists have been looking into carbon nanotubes, also known as CNTs, for water desalination. CNTs are layers of graphite wrapped into a tube. In the current desalination methods using CNT-based membranes, CNTs are functionalized at the tip or on the sidewall with positively charged functional groups like NH3- and negatively charged functional groups like COO-. In the desalination process, anions are attracted to the positive functional groups and the cations are attracted to the negative ones. With this method, there is membrane degradation because of the treatments received by the CNTs. Those treatments alter their structure and mechanical properties. Additionally, the membranes are not durable and cannot be washed. This research proposes two novel desalination methods using silver dewetted on CNT mats and microfluidic channels. The purpose of these two new methods is to avoid the degradation and durability issues encountered with the current methods, in order to keep up with the growing demand of drinking water. The first proposal is the creation of a CNT-based membrane decorated with silver nanoparticles by using thin silver film dewetting. The goal of this method is to retain salt ions by means of electrostatic forces. The rejection of salts is created by shining light at a specific wavelength in order to cross-link the silver nanoparticles with electric fields. During the process, the cross-linked silver nanoparticles attract the ions present in the feed water and leaving a filtrate free of salts. This method has the benefit of not changing the structure of the CNTs since no chemical process is involved. Besides the preservation of the structure, the approach allows to wash the ions out of the membrane and then allowing to have a reusable mat. Silver can be dewetted on a CNT mat because dewetting happens at critical temperatures of 573.15 Kelvin and 1073.15 Kelvin, which are far less than the melting temperature of CNT. A research by Epsich and al. Demonstrated that it is possible to decorate CNT mats with silver nanoislands via dewetting. Another research conducted by Seok and al. Revealed the electric field cross-linking and that dewetting can be done by pulse light technique. The approach is cost-effective and easy to operate. Figure 4 shows nanoparticle cross-linked by an electric field at specific wavelength. Compared to the first approach discussed in the previous slides, the second method will focus on the use of microfluidic channels to perform the desalination instead of a membrane. Here, a silver film will be dewetted inside or outside a silicon dioxide tube. Silver dewetting is generally performed on a solid substrate, but it has been proved that silver can be dewetted on a flexible substrate. Just like with the previous approach, the resulting silver nanoparticles will be cross-linked with electric fields by shining lights. Throughout the desalination process, the cross-linked silver nanoparticles will attract the ions present in the feed water, producing desalted water. The benefit of using this approach is that the substrate can be patterned, and dewetting on silicon dioxide is a very well-known process. The figure shows the dewetting process as well as the scanning electron microscope image of silver nanoparticles formed by 3 pulse light shots on the left and 6 shots on the right. Thank you for watching.